Hello again, it's Dave Giles here for the next lesson of Cambridge International IGCSE Physics, P2 Thermal Physics. Today we're looking at heat transfer, and I want you in this fairly short lesson to identify applications of conduction, convection, and radiation, and also identify in different scenarios whether the heat transfer method will be conduction, convection, or radiation, or multiple methods. So we'll start by looking at a place where heat is transferred via various different means. So this here is a warm cup of coffee, we'll assume. So inside the cup, heat or thermal energy rises through convection, and it also comes out of the cup via convection at the top here. Thermal radiation is emitted from the surface of all hot objects. And to get from the boiling water inside to travel through the cup, that is convection. Now, obviously, if you use, if you're taking something with you, you'd probably want to keep it hot for a long time if you're taking a cup of coffee or a cup of tea. So sometimes you might use a vacuum flask, which is designed to try and reduce the three methods of heat transfer. So it also keeps hot drinks hot and also keeps the cold drinks cold for longer, although probably more famous for keeping the hot drinks hot. So you've got a vacuum between the two layers of glass or steel, prevent heat leaving or entering by conduction, because heat can't travel via conduction if there's no particles. The plastic or cork lid is an insulator, and the screw top prevents convection current escaping from the flask. And finally, the walls have silver surfaces which prevent heat leaving or entering by radiation, because silver surfaces or shiny surfaces reflect infrared, so it'll send it back inside the thermos. Okay, so I've got some different examples here of um, things that are used to try and reduce heat loss. And I want you to decide whether each one is reducing heat loss via conduction, convection, or through radiation. Now, you might not know what cavity wall insulation is, so a very brief description is it's put in walls. So normally if you've got brick walls, there'll be a small gap in the middle, and that small gap is filled with cavity wall insulation. Okay, so let's have a look at them. So first one, cavity wall insulation helps reduce heat loss via convection, because it's a solid which fills the air gap between the walls. Carpet, so it helps prevent heat loss from your feet to the floor, and that's directly touching through solids, so it is conduction. Loft insulation next up. So loft insulation can be more than one method, but the main one is conduction. Foil behind the radiators is radiation, because your radiator is against the wall. If you put foil behind it, anything that's going back instead of into the room is just reflected back into the room. Curtains help reduce heat loss via convection. I suppose if you had them shiny, silver color, you could also help them reduce using the help reduce heat loss via radiation. Double glazing helps prevent heat loss via conduction. And finally, a draft excluder is going to reduce convection losses. Okay, so here are some heat transfer questions. I'll let you pause it and then have a go at the questions. Okay, the first one, which is a multiple choice from paper 2. So the diagram shows a frozen pond with surface of the ice slowly melting as the heat is transferred from the warmer air above it. By which process is heat transferred from the air to the ice? Now, if we're talking about heat from above, then you're not going to have any convection, because convection only heats up the area above. But you will have the other two, radiation and conduction. So it's going to be D, the answer. Okay, so question 2 here. A man in a cold room, 1 meter away from a heater. The heater is switched on and the man feels warmer almost immediately. How is thermal energy transferred from the heater to the man so quickly? So in the past, when we've looked at these kind of questions of a heater in the bottom or corner of a room, we talk about convection. So that might be your first thought. However, convection is a relatively slow process. The quicker way of transferring heat here is radiation. So the reason you feel so quickly is due to radiation. So the answer is C. And then finally, the paper 4 exam question, standard exam style question. I'll just put the mark scheme on. Okay, let you mark that. And that's it for today's lesson. The next lesson is going to be on, and that'll be the final lesson of this unit, will be on thermal equilibrium. I'll post a link in the description down below. Thank you very much, and I'll see you in the next video.